Good morning. This is Ralph Mendez. We're going to work on chapter 24 today. I'm sorry I did it yesterday, but somehow the video wasn't on. I have to do it all over again. All right. Number one, payback. Park is considered an investment, requires immediate payment of $32,000 and provides expected cash flows of $12,200 annually for 4 years. So, payback. So, what is payback? Here's a good article here. It's by Amy Gallo, and she's right here. She's a contributing editor at Harvard Business Review. And then right here, this is from April 18, 2016. Businesses need to make investments to grow. But how do you know which investments are likely to be worthwhile? There are a variety of methods to calculate a return on investment. Net present value. We're going to talk about that today. IRR rate, return. We're going to talk about that. Break even, we did that. But the simplest is payback. I talked with Joe Knight, author of HBR and businessliteracy.com. Payback is by far the most common ROI method used to express the return you're getting on an investment. How long until we get our money back? That's exactly what the method shows. The time it takes for the cash flow from the project to return the original investment. The shorter the payback period, the better. And it obviously has to be shorter than the life of the project. Otherwise, there's no reason to make the investment. If it's a long payback, you're probably not looking at a worthwhile investment. So let's do payback. So you take the cost of the project and you divide by the cash flow. So in this case, it's $32,000 cost. And the cash flows are 12.2, and it's 2.6 years. And all right, but now there's more complicated. So that's payback when you get your cash flow. Now here's uneven. Number one was even cash flows for 4 years. So now here you pay out the 290 and cash flow 70,000 in. So now it's minus 220. And then 40,000 comes in the next year. So now we're minus 180. And then 70,000 and we're minus 110. And then 200,000 come in. So now we're plus 90. And now we got 20,000 come in. So we're at 110. All right, so what is the payback? Well, it's something greater than 3. So it's 3 something. It's not 4 years at the end of, so it's 3 something. So now the way I approach it, and I seem to be wrong, is I take the fraction, you're minus 110, you make 200 the next year. So to me, it's taking a little over half the next year. So at the end of the year, 1, 2, 3. At the end of year 3, you're minus 110. 110 divided by 200,000. That means 0.55. So a little over half the year. And that's the way I'm thinking about it. But obviously I'm getting it wrong. So let's see here. I'll try again. So 3.5 years, 3.55 years. Round your payback period to 2 decimal places. Oh, okay. So I hope that makes sense to you. All right, how about another one? Straight line depreciation. So the first one was even cash flows. Number 2 was uneven cash flows. So now, though, the thing is, how do you get cash flow if you're given net income? Remember, sales minus cost of goods is gross profit minus expenses, including depreciation expense, gives you net income. But do you write a check for depreciation? No. And now also you should remember the cash flow statement. Net income plus the non-cash expenses. And depreciation is a non-cash expense. So now we got to see how much they've been depreciating. So wow, they're throwing a lot of things in here. 160, 0 salvage. So remember, it's cost minus salvage divided by life. Remember depreciation. Cost minus salvage divided by life. So it's 160 minus 0 divided by 5. So they're depreciating $2,000 a year every year. 5 times 32 is 160. So the cash flow is 32 plus the 10.7. So that's what, 42.7. All right. And then here it's 30, 40, 50, 58.7. Is that right? And here it's 89,000. Oops. I didn't want you over there. I guess it won't let me get there. So I guess I got to work at 160,000 minus plus 42.7 cash flow. So now I'm at minus 117,300. And then I add to that 58.7. So now I'm minus 58.6. And this is 89. And then I plus the 89. So then I end the year with 30,400. So it's somewhere in there, 2 point something years. So let's do it again. You're minus 58 at the end of year 2, and you make 89. So it's going to take quite a bit of the next year to get to break even. So I take 58,000 divided by 89, and I think it's 65 because it's more than half the year. So I think it's 2.66 because it says, no, it says round to 3. All right, so I'm going to 2.658. I'm going to try that. All right, so net income plus the non-cash expense depreciation gives you your cash flow. All right, and then it's trying to, so that's payback. That's payback method. That's accelerated depreciation. Y'all can do that one. Just remember your book value is what you paid. Remember, and then 40%, 245 times 0.4. Why is it 0.4? 5 years, so straight line would be 1/5 in double declining balance, means you get 2/5, double the straight line rate. And 2/5 is the same as 40%. So that means 98,000 is your depreciation. So your accumulated is 98 at the end of 1 year. And then 245 plus that is 147 is your book value at the end of the year. So that's your beginning book value the next year. And you multiply that times 40% and you get 58.8. Okay. And then you add the 98 plus the 58.8 and keep going. And that's how you get, and then the book value is 245 minus that is 88.2. And again, that's your start of the next year, and multiply that by 40%. All right, so I think you can get that one. All right, let's try number 5. Payback computation. This is just asking you, new operating system, a machine cost will generate, it's just asking you to do 2 projects. But remember, what's the formula for cash flow? Investment divided by the cash flow. And you've got to figure out the cash flow. All right. Number 6, probably going to a new method now. That's payback. So you did 5 problems on payback, 5 problems. And again, payback is a very, it's the simplest method, and it's a lot of people use it. All right. All right. That's payback. Now, what's the next one we're going to do? Net present value. Well, net present value, but what about just plain present value? All right. Present value is bringing back cash flow. So here's 2021, 2022, 23, 24, 25. And in this case, this is a bond, and it's $10,000 bond. So after 5 years, you get the face value, the $10,000, and you get interest every 6 months of $500. 500, 500, 500, 500. Well, you discount and bring all these things back to today. And what are they worth today? So that's the present value. Well, the net present value adds an additional step. So let's look at that. Net present value is the difference between the present value of the cash flows and then the present value of the outflow. So if you have to pay for the equipment today, that's an outflow. Net present value is used in capital budgeting investment planning to analyze the profitability of a project. All right, so let's go try this one. So the annual cash flow of this project, we got to put out 21.5, expected cash flows of 68 annually, 6,800 for 4 years. But it wants an 8% return on its investments. Now that's called the discount rate. So what is this discount rate? The discount rate is the interest rate used to determine the present value of future cash flows in a discounted cash flow analysis. This helps determine if the future cash from a project or investment is worth more than the capital outlay needed to fund the project or investment in the present. So you have to use 8%, and it's not a single time 6,800. You see, it's more like this cash flow is 6,800 for 4 years. So it's like this, 6,800, 6,800, 6,800, 6,800. So because they're equal, you can use the annuity table. All right, so let's stop share here just for a minute. All right, so let's try this problem. What is the net present value? So here, select the chart. It's the present value of it because it's more than one time the 6,800. So it's not just $1. It's not compounding growing. It's this one here, present value of a series of payments. So now, so here we can see it's an annuity right here, present value of annuity. And there's the math algebraic formula. So you could calculate any of these numbers they have here by 1 divided by 1 plus I, which is the interest rate, raised to the number of periods, divided by the interest. Okay, now what are our interest? We're supposed to use 8% 4 years, 4 periods. 8% for 3.3121. 3.3121. Now, what's else? At the end, what else does it do here? We got to pay for this thing, less the outflow. And that is not discounted because it's right now today. So that's 21,555. So you would subtract that. 22,522 minus 21,555 equals 967. So the net present value, the present value of the future cash flows minus what you have to pay for it gives you the net present value. And so would you, based on, should you Park invest? Yes, because it's greater, the net present value is greater than 8%. Now, if you don't mind, I'm going to go change this now because I want to raise this now to 9. I want to show you something here. Let's just try it. What is it for 4 years and 9%? 3.2397. 3.2397. 2.2397. Really? That changes that much? 4 periods. 3.2397. 3.2397. So the present value is still greater, 22 in the cash outflow. So it's still 22,030 minus 21,555. So now it's down to 475. So now I'm going to try 10%. 4 and 10, 3.1699. 3.1699. Look, the present value is the same as the outflow. And that, by going up on the discount rate, we went from 8 to 9 to 10. So at 10, the present value of the future cash flows, which is 24, 25, 26, $27,000. But we're saying, hey, this is our opportunity cost. This is so right here, the discount rate is the interest rate used to determine the present value. This helps determine if the future values from a project will be worth more than the capital. So you got to pay out money. And money in the future is not worth as much because of inflation and opportunity cost. So now we found the IRR. The IRR is a metric used in financial analysis to estimate the profitability of potential investment. The internal rate of return is a discount rate that makes the net present value of the cash flows equal to 0. So actually, that's kind of telling you that that project returns 10%. It's greater than 8, it was positive. At 9, it was positive. And at 10, it's 0. So that's kind of telling you, hey, this project makes 10%. Okay, very good. All right. Thank you all for being patient with me there. Let's do internal rate of return again. What is it here? Immediate outpayment of 21, expected cash flows of 6,800. They want 8%. What is the internal rate of return? So to get the internal rate of return, you take the cost divided by the cash flow. So we're going to take this, the present value factor and the internal rate of return. Now, let me show you what I mean by that. This is a series of payments. So take 21,555, the cost, divided by the 6,800 cash flow, which is the same thing as payback. So use the payback formula, and what do you get? The cost divided by the cash flow gives you this 3.1699. So now, because it's a series of payments equal, we're going to go to this, and we're going to go to 4 years and see if we can find that number. 3.1699. 3.1699, and there it is. You go up, and it's 10%. So there's that number, the payback number for 4 periods, and that tells us what the IRR is. Now, and the reason why I did it for you on the other one, 3.1699, is I thought it was easier to see when we did it over here, how we kept raising it. We kept raising it until 0. We did 8, and then we did 9, and we did 10. So in this one, they just throw this at you and say, hey, find the internal rate of return. Well, that's why I introduced it the other way. Based on the internal rate of return of 10%, should Park make the investment? Yeah, because they want 8%, and we figured out it makes 10. So yes. All right. And then this is your first time maybe doing internal rate of return, but these are the best methods because they take into account that money. This is why these are the best, better than payback, better than accounting rate of return, because they take into a fact that these $500 is worth less than that $500, and that $10,000 5 years from now is not worth $10,000 today, because inflation has eroded the value of that dollar, made it reduce the purchasing power, and you've also opportunity costs. So think about it. If you get 500 today, you could invest it and maybe it'll grow to something. So you're not going to, the value of 500 5 years from now is not the same. It's less than today. All right, now here's a new one called the accounting rate of return. So let's see if I have a formula for here. Here's this accounting rate of return, and this is not intuitive to me. It's the book value at the beginning plus the book value at the end of the project divided by 2. So the book value at the beginning plus the book value at the end divided by 2. So here, it says here the investment is 46.5. And if I tell you it's going to last 3 years, what's the average investment? Because you take the net income divided by the average investment. Well, to me, in my mind, I would have taken 46 divided by 3, the average investment each year, around 15,000. But no, for this method, after tax income, and you take the book value at the beginning plus the book value at the end and divide that by 2. So 46.5 plus 8,100 is 54.6 divided by 2. So they're saying the average investment is 27.3. And I just can't think about that. It's not intuitive to me, this formula. So hopefully you can think of a better way to understand it. Average investment to me would have just been 46. And I'm going to get 8,100 at the end. So I would have minused it. And I would have said, oh, we got 36 tied up because we're going to get back, and then divided by 3. I would have thought it's around 12 or something. So I don't understand that one exactly. It's just not okay. All right. Net present value again. So we already did one like this. An investment expected to generate cash flows. So you're going to get cash flows of 3,100 for 3 years, and you're going to get a salvage value at the end. So you got to go to the tables and find the factor. Now, because this is for 3 years and it's the same amount, that's an annuity. But this one here is only one time you get the salvage. So that's 8,100. So that gives you the present value. And then that gives you the present value of those cash flows. But then you got to subtract what you got to pay for it. All right. And then that tells you if this is positive or negative. All right. Net present value again. Now here, the 370 is just a little bit different format here. So 370, let's see, use appropriate factor table, round all present values. But here you got 160,000 and 92 and 107. Well, right away, these cash flows, 160, 92, and 107, they add up to 359, and that the project alone costs 370. So you know it's not going to be accepted. It's not good. But anyway, you can't use the annuity because the payments aren't equal. You can't use the annuity because the payments aren't equal. You have to use this one. So 6%, and you have to write down, you got to write down the factors at 6% for 1 period, 2 periods, and then, so it's 9434, 0.8900, and 0.8396, and then you got to do the math. But your total cash flows are less than just what you got to pay for it. So you can see that it's not going to be a good project. So you can see right away the present value's 322 and the thing costs 70, is minus 47. Don't do it. It's not a good project. All right, net present value with a salvage. So here again, you put in the cash flows and a minus, but 0 salvage, sorry. So it's the same thing as the last one. All right, again, another net present value. So present value minus the amount to be invested. All right. Same thing. And if it's positive, you accept it. Another net present value. So we're just getting you to practice over and over again. Present value. The cash flows, are they even? Here you're just doing two different projects. An operating machine, and here is a machine. All right. So you're going to put the cash flow, expect to have a cost of 520. So that goes down here somewhere. That's your cash outflow. And this is the present value of your cash flows, inflows. And this subtracted that gives you your net present value. Accounting rate of return, again, that is your after annual net income divided by this average annual investment. And here it's average $5,000 net income. And how do you get the average investment? 200,000 has 9 years and a 40,000. So you take 240, book value at the beginning, book value at the end. 200 plus 40 is 240 divided by 2. And cost 200,000 and 40,000. So the average investment oh, I'm so dumb. 240. It's 120. There we go. Accounting rate of return. Payback and accounting rate of return. So in this one here, they want you to use the payback, and over here, accounting rate of return. So here, what's payback formula? Cost divided by the cash flow. And over here, what is it? Annual net income after tax divided by the average investment. All right. Okay. And let me just